Welcome back. Today we're going to start working with the Arduino. So let me run you through some stuff in case you've forgotten or you haven't used one before. So this is an Arduino microprocessor. It can take inputs, process that data, and then send signals out to more stuff. So you can read a joystick and then tell a motor to run. It can turn LEDs on. It can do all kinds of interesting things. And it does all of this with reading and sending voltages in and out through the various pins. The pins are these holes here on this side and the holes here on this side. This is where you can attach wires. The pins are labeled, so you can see on this edge here, they have labels on them. That's probably upside down for you, I apologize. They have labels on them what they are. The A0 to A5, these are called analog in pins. These are going to be used primarily for sensors and reading things like potentiometers and joysticks. There's a VN pin. The VN pin powers the Arduino, so later on when we put an Arduino into the sub, we're going to need to put a wire into the VN slot to power the Arduino. The next two are G and D. Those are ground pins. They're the exact same ground pin. There's a third one on the other side. They're all connected to each other. It does not matter which one you use. The next one is a pin called 5-volt pin. This has a constant 5-volt power going out. So if you need to power some other device, you can use this 5-volt pin to do it. It's not enough energy to power our big motors. It can power a really small motor, but it runs out of energy power pretty fast, so it's limited. The next one's a 3.3 volts. So some sensors will require 3.3 volts instead of 5 volts. You'd want to make sure to use that pin for those. We'll have some like that in our project. This is a reset pin, and then IO ref pin. We don't need these two pins. Basically, the reset pin, if you send electricity into it, it's like pushing the reset button on the Arduino, just resets it. We won't use either of those pins. On the other side are the digital pins. So let me see if I can hold it. Yeah, probably like this. You can see it still. The digital pins here have a ground pin here as well. So all three of these ground pins are connected. And then it's pins 13 all the way down to 0. We're going to try to avoid using 0 and 1. They're used for some data transfer stuff, so they'll cause some weird behavior sometime. Notice how pins 3, 5, 6, 10, and 11, excuse me, and I think I missed 9, and 9 all have a little tilde next to them. These are special pins. So these pins are called digital pins, and they can just be turned on or off. There's no like half voltages they can be sent out. Either 0 volts or 5 volts, one or the two. They're great for things like turning on and off LEDs or other different things where just an on and off command can do it. They can also read voltage from outside, but all they read is whether there is low voltage or high voltage. They can't read, excuse me, they can't read intermediate voltages like 3.7 volts. They can only read whether it's low or high voltage, whereas the analog pins can read intermediate voltages. So we'll use those for sensors usually. All right, the tilde pins are special. They can actually output different voltages. We'll use these to control the motors. More on that later. That's the basics of the Arduino. Also, this port right here is for plugging into your laptop, and this is for applying an outside power source. The Arduino will get all of its power from the USB cable from your computer, so we won't use this. We will hook up we'll hook this up to our battery later, but we'll see that in a while. For now, we'll get all of our power from the USB cable. This thing over here is called a breadboard. It's used for easily making a bunch of connections. And here's a common one we need. We only had one 5-volt pin over here, but we're going to need to be able to connect a lot of different devices to 5 volts sometimes. So what we can do to extend the number of pins we have is we can take a wire, and you have these jumper wires in your kit. I'm going to take a wire, I'm going to plug it into the 5-volt pin here on the Arduino. Once I plug this in, 5-volt electrons will flow through this wire now, and I'm going to just route this around kind of out of the way and put it into the positive rail on the breadboard right here. So these two outside rails, all of these holes here, all these pins, are all connected electrically on the inside. It's a metal strip running it for all of them. So the moment I drop 5-volt electrons in any of these holes, all of the rest of the holes can now access 5-volt electrons. So if I need to power something, I can plug it anywhere in this positive strip and get power for it. Super convenient thing to do. I'm gonna take a second one and come over to one of the ground pins here. And I'm gonna put it in here. And then I'm gonna run this one, because again, we're gonna need lots of connections for ground. We only have 3, we're gonna need more than that. I'm gonna put it into the negative one. So now every one of these holes, all the way down this whole side, these are all now grounded. So if I need to have a ground for something, I can plug into any of these holes and I'm good, or any of these pins. If I need 5 volts, I can plug in any of these pins. The same thing over here. These are all connected to each other, and these are all connected to each other as well. I could run another wire. If I needed more than these, I could run another wire from this positive to this positive, which means now 5-volt electrons are in this rail and they're in this positive rail here. I can do the same thing for ground. Sometimes we'll do that because we don't want to have our wires crossing so much. We'll want to use the ones on this side instead. Okay, so I'm going to pull this last wire out. The nice thing about breadboards is you can pull wires out and put them in very easily instead of like twisting the wires together or soldering them, which is a more permanent connection. This allows you to play around, make mistakes, fix things, and kind of go from there. All right, now we need to do our potentiometer. Let's wire this thing up. Okay, so what you'll need is your potentiometer, and you'll need 3 of these jumper wires. They have a socket on this side and a plug on this side. These can be easily separated. They don't need to stay together. They might even be easier to separate them. We'll see. I'm going to choose, doesn't matter what color they are either. I'm just going to put them on here one at a time. So they're kind of hard to get on. Don't try to put them on carefully so you don't bend everything up. And I know my outside pins, one has to go to 5 volts, the other has to go to ground. Doesn't matter which way it is. It just depends on whether do I want rotating counterclockwise to be going full blast or going clockwise. I think going clockwise to me makes more sense for full blast. So I'm going to put the 5-volt on the right side, not the left side. So I'm going to take this one on the right side and put it into the positive rail here, because that's where I get my 5-volt electrons from. The outside one is going to go into the ground. And then I'm left with this middle pin, and this middle pin is going to go to one of the A pins over here, the analog pins. I'm going to choose A0. Doesn't matter which one you choose, but you need to know which one you choose, because when you program, that's how you're going to tell the Arduino where to look for the signal. So when I turn this knob, the voltage of the electrons going to this pin will go from 5 all the way down to 0, and that is where I'm going to be able to read and tell what's going on with my knob. I've got to use one of the A0 pins because a potentiometer isn't just off or on. Digital pins are for off-on stuff. Analog pins are when you have other values you want in the intermediate. All right, so hopefully that was a decent refresher of the Arduino. We're now powered, or we're now wired up and ready to do some programming.